Hello everyone, welcome you all onto the SVP online classes study channel. We were discussing about the salts in the previous classes, right? And our today's topic is washing soda. From the discussion of yesterday's class, we came to know that whenever sodium hydrogen carbonate is getting heated, at that time Na2CO3 or sodium carbonate is formed, right? Along with the relation of H2O plus CO2. Okay. So whenever baking soda or sodium hydrogen carbonate or sodium bicarbonate is getting heated, at that time sodium carbonate is formed, right? Whenever this sodium carbonate is recrystallizes along with the water molecules, if the sodium carbonate recrystallizes with the 10 water molecules, then Na2CO3 dot 10 H2O is formed. This Na2CO3 dot 10 H2O, this is called washing soda, right? This is called washing soda. Okay, so you know that whenever sodium bicarbonate is getting heated, at that time sodium carbonate is formed, and whenever crystals of sodium carbonate are formed along with the water molecules, then washing soda is there, right? So let me first discuss that what is the crystallization, how does washing soda obtained from the sodium carbonate, right? And what does it mean by 10 H2O or 10 water molecules, right? These 10 H2O, these water molecules are called water of crystallization. These are called as what? Water of crystallization. It means these are the water molecules which are used in the process of crystallization. Crystallization is what? Crystallization is a process by which crystals of salt is formed. By which crystals of salt are formed. That process is called crystallization. मतलब ऐसी प्रोसेस जिससे साल्ट के क्रिस्टल्स का फॉर्मेशन होता है, उस प्रोसेस को हम क्या बोलते हैं? क्रिस्टलाइजेशन बोलते हैं, राइट? एंड इन दिस प्रोसेस सम अमाउंट ऑफ वाटर मोलिक्यूल्स आर इन्वॉल्व्ड. So the water molecules which are used in the process of crystallization, that are called water of crystallization. इसको हम इस तरीके से देख सकते हैं कि let we consider a simple salt, and the most simple salt for us is what? NaCl, right? If we heat this NaCl after putting it into the frying pan, and if it gets heated, then what we will observe? We will observe that a paste of NaCl is formed. A paste of NaCl is formed. जब भी हम किसी साल्ट को हीट करते हैं without mixing it into the water or any other solvent, if you are heating a salt, then that salt is converted into a paste, right? Or a paste of salt is formed. This paste of salt is formed due to the water molecules which are already present into the salt. It means this paste is there because of water molecules. इसका मतलब हम ऐसे कह सकते हैं कि किसी भी साल्ट को अगर हम हीट कर रहे हैं तो वो साल्ट का एक सॉल्यूशन फॉर्म होता है, और अ पेस्ट लाइक सॉल्यूशन इज फॉर्म्ड, और अ पेस्ट लाइक सॉल्यूशन इज फॉर्म्ड. दैट पेस्ट लाइक सॉल्यूशन इज कॉल्ड molten solution. This solution? Molten solution. It means the solution which is formed by just heating of salt, that is called molten solution, right? मतलब अगर हम किसी भी साल्ट को गर्म कर रहे हैं तो एक पेस्ट फॉर्म होगा, दैट पेस्ट इज कॉल्ड मोल्टन सॉल्यूशन. हाउ डज दिस पेस्ट फॉर्म? इट मीन्स अगर ये पेस्ट फॉर्म हो रहा है तो ऐसा है कि उस साल्ट के अंदर पहले से कुछ न कुछ वाटर मोलिक्यूल्स प्रेजेंट होंगे, राइट? एंड फ्रॉम वेयर दीज वाटर मोलिक्यूल्स बी देयर इनसाइड दैट साल्ट. These water molecules are introduced at the time of crystallization whenever the crystals of salts were formed, right? ये water molecules salt के अंदर कहाँ से आए? जब salt का formation हुआ, और उन salt के formation में कुछ एक water molecules का introduction हुआ, और the crystallization is there because of involvement of some water molecules, right? तो ऐसे water molecules जो कि किसी भी क्रिस्टल के क्रिस्टलाइजेशन में या किसी भी साल्ट की क्रिस्टलाइजेशन में हेल्प करते हैं, उनको हम क्या बोलते हैं? वाटर ऑफ क्रिस्टलाइजेशन बोलते हैं. क्या बोलेंगे? वाटर ऑफ क्रिस्टलाइजेशन. सो हाउ दीज वाटर ऑफ क्रिस्टलाइजेशन कैन बी डिफाइंड? दैट द वाटर मोलिक्यूल्स विच आर यूज्ड इन द प्रोसेस ऑफ क्रिस्टलाइजेशन बाय विच अ साल्ट इज फॉर्म्ड. किसी भी साल्ट के क्रिस्टल्स फॉर्म होने की प्रोसेस में जो वाटर मोलिक्यूल्स इन्वॉल्व होते हैं या फिर जो वाटर मोलिक्यूल्स काम में आते हैं, उनको हम क्या बोलेंगे? वाटर ऑफ क्रिस्टलाइजेशन बोलेंगे, राइट। So in this case, whenever sodium carbonate, this sodium carbonate is there, if this sodium carbonate is recrystallized, or if its crystallization takes place along with the 10 molecules of water, then Na2CO3.10H2O is formed. This Na2CO3.10H2O is called washing soda, right? And this Na2CO3.10H2O is formed due to the process of crystallization. I hope that you have understood that what does it mean by crystallization. क्रिस्टलाइजेशन वो प्रोसेस है जिससे किसी साल्ट के क्रिस्टल्स फॉर्म होते हैं, राइट। क्रिस्टल्स का मतलब ये है कि जब भी हम कोई साल्ट देखते हैं, दैट साल्ट इज in the form of crystals. For example, if we consider the NaCl's crystals, right, the NaCl not in the powdered form but the original salt that we see, that is having its crystals, right. That NaCl's crystal is so hard and we cannot imagine the presence of water component into it, but whenever we heat that NaCl's crystal, then it is converted into a paste. That paste is called molten solution, and the appearance of that paste indicates that some amount of water molecules were introduced at the time of formation of the crystals of that NaCl. Is it clear, right? तो ऐसे वाटर मोलिक्यूल्स जो कि फॉर्मेशन ऑफ क्रिस्टल में हेल्प करते हैं, उसको हम क्या बोलते हैं, उसको हम बोलते हैं वाटर ऑफ crystallization, and this process is called crystallization, right? It means now we can say that the washing soda is formed by the crystallization of sodium carbonate. Washing soda is formed by the crystallization of sodium carbonate, and this sodium carbonate is obtained by heating of sodium bicarbonate. Whenever we heat sodium bicarbonate, at that time Na2CO3 is formed, right? Okay, and whenever this Na2CO3 is crystallizes, at that time washing soda is formed, right? So in the board's exam, it is generally asked that what do you mean by water of crystallization. So how would you define the water of crystallization? The water molecules which are used in the preparation of crystals of a salt, right? ऐसे वाटर मोलिक्यूल्स जो कि किसी भी साल्ट के क्रिस्टल्स की प्रिपरेशन में यूज़ में आते हैं, उनको हम क्या बोलते हैं, वाटर ऑफ क्रिस्टलाइजेशन बोलते हैं, राइट. सो Na2CO3 itself is called sodium bicarbonate, and whenever it is getting combined along with the 10 molecules of water, then it is called washing soda. This washing soda is an important salt and it is used in number of things. It is used in the soaps and the glass industry. The washing soda, as the name signifies, that it is used in soaps and glass industry, right? It is used in the synthesis of some compounds which are formed by sodium. कुछ एक स्पेशल केमिकल कंपाउंड्स की फॉर्मेशन के अंदर भी वॉशिंग सोडा यूज में होता है, जैसे कि बोरेक्स फॉर्लाइज वोट Na2B4O7. Okay, it can be used as an antacid. This can be used to nullify the effect of acid. Similarly, the sodium carbonate is used, or washing soda is used to remove the permanent hardness present in the water. मतलब ये जो वॉशिंग सोडा है, ये वॉशिंग सोडा किस किस के काम में आता है? ये वॉशिंग सोडा सोप्स इंडस्ट्री में काम आ सकता है, ग्लास इंडस्ट्री में काम आ सकता है, अलग अलग केमिकल्स की सिंथेसिस में काम में आता है, वाटर की प्योरीफिकेशन में काम में आता है, एंड it can also be used as an antacid. Antacids are those substances which are used to nullify the effect of acid. Okay, so from this topic it is very important that what do we mean by water of crystallization, right? Water of crystallization. Okay, and how does washing soda is formed? By the recrystallization process of Na2CO3 or sodium bicarbonate along with the 10 molecules of water. Okay, our last and final topic of this chapter is plaster of Paris. This is very important, and 19% chance is there that this will be asked in the exam. This plaster of Paris, generally called as POP, right? Its name is what? POP. And in general we can also know it as white cement. Nowadays the white cement that we are having, that is plaster of Paris. Similarly, all those kind of putties like the birla putty, all those putties are plaster of Paris. And nowadays the putty or the white cement is used in each and every construction works in order to make the walls smooth, right? In order to make the walls smooth, we see that POP or birla putty is applied all onto the walls in the construction work, right? So that is plaster of Paris. प्लास्टर ऑफ पेरिस कौन सा होता है? जो वाइट सीमेंट हम लेते हैं या फिर कंस्ट्रक्शन वर्क के अंदर जो पीओपी यूज़ में आता है या बिरला पुट्टी यूज़ में आती है, उसको हम क्या बोलते हैं? प्लास्टर ऑफ पेरिस बोलते हैं. प्लास्टर ऑफ पेरिस हैज़ सम प्रॉपर्टीज़ by which it is very useful in the construction as well as in the medical field, right? और plaster of Paris की property क्या होगी? Whenever it is mixed into the water, at that time it becomes into the solid, right? It becomes in solid form, or it's settled in terms of solid, so it becomes very useful, right? So plaster of Paris is obtained by a salt that is called gypsum. Plaster of Paris obtained होता है किससे? gypsum से. Gypsum is having its formula CaSO4 twice of H2O. What is its formula? CaSO4 dot twice of H2O. Right? CaSO4 means calcium sulfate dot twice of H2O. Here twice of H2O represents the water of crystallization. Twice of H2O is what? Water of crystallization. Water of crystallization. This gypsum is present in terms of solid mass, and whenever this gypsum is getting heated at a controlled temperature, that temperature is 373 Kelvin. If gypsum is heated at 373 Kelvin, at that time plaster of Paris is formed. And what happens whenever gypsum is heated at 373 Kelvin? At that time, if gypsum is heated at 373 Kelvin, then 1.5 molecule out of 2 H2O, 1.5 molecule of H2O is getting released. 1.5 water molecule gets released, and what is left? CaSO4 dot half H2O is left. So on heating of gypsum at 373 Kelvin will produce CaSO3 dot half H2O. This is not the whole molecule of water, this is only the half molecule of water which is used in the crystallization of POP. So CaSO4 dot half H2O, this is called calcium sulfate hemihydrate, because this is half, and we know that half we can say semi, right? For example, circle, and if we are considering the half circle, then it is semicircle. Similarly, if we are considering the half water molecule, then this is what? Semi or hemi, right? And hydrate means water. So CaSO4 dot half H2O is called calcium sulfate hemihydrate, and this calcium sulfate hemihydrate is known as POP. Calcium sulfate hemihydrate is called POP. Whenever gypsum is heated at 373 Kelvin, at that time POP is formed, and this POP is a white powder. This is in the form of white powder. This POP is present in terms of white powder, right? This white powder we buy from the market, right? This plaster of Paris is having a unique property that whenever this plaster of Paris come in contact with the water, then it absorbs the 1.5 molecules and again converted into the gypsum, which is solid in nature, right? तो जैसे ही plaster of Paris वाटर के साथ रिएक्ट करता है, at that time it is again converted into the gypsum, and this gypsum is very hard. क्या होगा अगर प्लास्टर ऑफ पेरिस वाटर मॉलिक्यूल्स के कांटेक्ट में आएगा तो वापस से जिप्सम फॉर्म करेगा, और जिप्सम इज़ व्हाट? वेरी हार्ड. ऑन पासिंग ऑफ टाइम दिस जिप्सम बिकम्स हार्डर एंड हार्डर एंड हार्डर. दिस प्लास्टर ऑफ पेरिस बिकम्स हार्डर एंड हार्डर ड्यू टू द फॉर्मेशन ऑफ gypsum, due to formation of this gypsum, and this is the unique property by which this plaster of Paris is quite important, right? So the unique property is what? Whenever plaster of Paris react with the water molecules, at that time it becomes hard due to the formation of gypsum, okay? As we know that each and everything is exposed in the atmosphere, and in the atmosphere water vapors are present. Right? Similarly, if we left this plaster of Paris in open, then it may absorb the water vapors, right? If calcium sulfate hemihydrate or POP is placed in open, then it may absorb the water vapor from the atmosphere, and if it absorbs the water vapor from the atmosphere, then it can be converted into the gypsum, or it can become hard. ये gypsum में convert हो सकता है और hard हो सकता है. That's why it is necessary to place this पीओपी इन एयर टाइट कंटेनर। ये इसीलिए ज़रूरी है कि इसकी पैकिंग हमको क्या करनी होती है, एयर टाइट पैकिंग करनी होती है। इट मीन्स पीओपी जब एटमॉस्फेयर में खुला रह जाएगा तो वाटर मोलिक्यूल्स का एब्जॉर्प्शन कर लेगा, एंड ड्यू टू द एब्जॉर्प्शन ऑफ दोज वाटर मोलिक्यूल्स इट कैन बी कन्वर्टेड इनटू द सॉलिड हार्ड मास, राइट, बाय द फॉर्मेशन ऑफ gypsum. And when once it is converted into the hard mass or in the gypsum, then it is no longer in use. Okay, that's why we need to store the plaster of Paris in the airtight containers. So this is the very important question which might be asked in the exam, that why do we store POP in airtight containers, or why do we store the POP in एयर टाइट पैकिंग, राइट। हमें प्लास्टर ऑफ पेरिस को एयर टाइट पैकिंग में क्यों रखना चाहिए? बिकॉज इट में एब्जॉर्ब्स वाटर वेपर्स और वाटर मोलिक्यूल्स फ्रॉम द एटमॉस्फेयर एंड इट कैन बिकम हार्ड बाय फॉर्मेशन ऑफ जिप्सम. सो इन ऑर्डर टू प्रिवेंट दिस वी शुड store the plaster of Paris in airtight packets or in airtight container. Is it clear? This question can be asked in the different manner, or it can be asked like this, that what would happen whenever plaster of Paris is left in open. क्या होगा जब plaster of Paris को हम open में छोड़ देंगे? If we left the plaster of Paris in open, then it may absorb the water molecules and it can be converted into the hard mass or in solid mass by the formation of gypsum, right? Okay, so in these two ways the same question can be asked, but the answer is same. Either it can be asked in the form why should we store the POP in airtight containers, or it might be asked in the form that what would happen whenever POP is left in open. So क्या होगा अगर हम POP को ओपन में रखते हैं तो वाटर मोलिक्यूल्स का एब्जॉर्प्शन कर लेगा, और वाटर मोलिक्यूल्स का अगर एब्जॉर्प्शन होगा तो वो सॉलिड मास में कन्वर्ट हो जाएगा, और सॉलिड मास में कन्वर्ट होगा वो किसकी वजह से होगा? बाय द फॉर्मेशन ऑफ जिप्सम, राइट. दिस इज द प्रॉपर्टी बाय विच it is very useful in the construction work. Whenever the POP is applied over the walls in construction one, at that time it is like a paste, right, and with the passage of time it becomes harder and harder and harder. जब भी POP walls के ऊपर या कहीं पे भी अप्लाई करते हैं तो वो इनिशियली क्या होता है, पेस्ट जैसा होता है, लेकिन टाइम के साथ में वो क्या होता जाता है, हार्ड होता जाता है, हार्ड होता जाता है, हार्ड होता जाता है, राइट. सो by this property the POP is very useful in our day-to-day activities, right. What can be its uses? POP is used in construction work. This is in order to make the surface smooth. POP किस में काम में आता है? कंस्ट्रक्शन वर्क में काम आता है, जब ताकि सरफेस को क्या बना सके, स्मूथ बना सके, राइट. इट इज़ ऑल्सो यूज्ड इन मेकिंग टॉयज और मटेरियल्स फॉर डेकोरेशन एक्सेट्रा, राइट. बाय द यूज ऑफ POP स्मॉल टॉयज और डेकोरेटिव आइटम्स भी बनते हैं, ठीक. एंड यू नो दैट whenever a bone is getting fractured, at that time a plaster is there around the bones in order to hold them in a right position, right. So the powder by which that plaster is formed in the medical field, that plaster is POP और plaster of Paris. क्या करते हैं? फ्रैक्चर्ड बोन्स को ज्वाइन करने के लिए भी किसका यूज होता है? POP का यूज में होता है, या फिर प्लास्टर ऑफ पेरिस का यूज में होता है. वैन एवर अ बोन इज गेटिंग फ्रैक्चर्ड, एट दैट टाइम द डॉक्टर अरेंजेस those bones in a proper way, and in order to hold those bones in a same place, that doctor applied a paste over the hand. That पेस्ट बिकम्स हार्डर एंड हार्डर एंड हार्डर विद द पैसेज ऑफ टाइम. जो भी बोन्स को हम जॉइंट कराते हैं, उस जॉइंट कराने के चारों तरफ डॉक्टर एक प्लास्टर पैक करता है. और अगर आपने देखा हो कभी तो प्लास्टर में वो पेस्ट यूज में लेता है. वो पेस्ट को उसको एक पर्टिकुलर डायरेक्शन के अंदर अप्लाई करता है, और उस पर्टिकुलर डायरेक्शन में अप्लाई करने के बाद में उसको एज इट इज़ छोड़ देता है. विद द पैसेज ऑफ टाइम दैट बिकम्स हार्डर एंड हार्डर एंड हार्डर, राइट. एंड आफ्टर दैट द बोन्स विल नॉट मूव. बोन्स उसी एक पोजीशन में रहती है, बोन्स मूव नहीं होती, एंड आफ्टर सम टाइम दोज बोन्स विल जॉइन, राइट. तो फ्रैक्चर्ड बोन्स में प्लास्टर बांधने के लिए किसका यूज में आता है? POP का यूज में आता है, राइट. प्लास्टर ऑफ पेरिस कैन ऑल्सो बी यूज्ड इन order to make statues. Statues means whenever you go to the market, at that time you may see a number of statues outside the showrooms or outside the ready-made garment shops especially, right? So those statues are formed by plaster of Paris. वो सारे स्टेचूज किससे बनते हैं? प्लास्टर ऑफ पेरिस से बनते हैं, राइट? दिस प्लास्टर ऑफ पेरिस इज़ वेरी इंपॉर्टेंट इन टर्म्स ऑफ एग्जामिनेशन पॉइंट ऑफ व्यू, राइट? हाउ दिस प्लास्टर ऑफ पेरिस इज फॉर्म्ड, what is its unique property, why should we place it in the airtight container, and why should we not left it in open, okay? And how does it useful in the medical field? In the medical field it is used to join the fractured bond by applying a plaster on the bones, right? So you should go through the POP. One question is generally asked about the plaster of Paris, and that question lies in its formula. We know that the POP's formula is CaSO4 dot half H2O. CaSO4 dot half H2O, right? This is the formula of POP. If we multiply this formula by 2, then what we can write? Twice of CaSO4 dot, if this 1 upon 2 H2O is multiplied by 2, then it becomes H2O. So plaster of Paris formula can also be given as twice of CaSO4 dot H2O. plaster of Paris का formula कैसे भी दिया जा सकता है? twice of CaSO4 dot H2O की में से भी दिया जा सकता है. It means if anywhere if you found twice of CaSO4 dot H2O as a formula of plaster of Paris, then you would not confuse for this. So this was all about of our second chapter of 10th class syllabus, that was acids, bases and salts. I hope that you have understood all the concepts which are prescribed in this chapter. If you have any problem, then you can comment in the comment section of the video, or you can come onto the direct chat to me, right? So after studying or after go through the whole notes, just try to solve the exercise of the chapter which is given in the NCERT book, okay? So keep studying, keep learning, stay at your home, be safe, protect your family and enjoy the melody of life. Thank you.